Hi, welcome to this video, this is my own DAC90A Bush. Taking the knobs off so far. It's a lovely cabinet, it's a lovely radio. I'm about to take the chassis out. I'm going to modify it. Now, I've wanted to do this for years. In fact, I've wanted to do this for decades. Never actually got round to it. I want, if I can, to fit a mains transformer. Possibly not this one, I've got to find one. But I want to fit a mains transformer in place of the dropper. So I can then have an earthed chassis, far less heat produced. All the heat with this back corner here gets hot. Obviously there's quite a lot to it. I've got to change the valves from the U series to the E series, so I've got 6.3 volt heaters. I've got to wire the valve heaters in parallel rather than in series. I've got to find somewhere to mount the mains dropper, the mains transformer. I don't think it'll fit where the mains dropper is at the moment. I don't know where else on the chassis. Once I've got the chassis out, I'm going to have a look. But the first thing I want to do is find the smaller mains transformer as I can. I've got another one similar to this that will supply the voltage and the current that we need to power the radio. So, as I say, I wanted to do this for years, decades. Never actually got round to it. I should be getting on with a customer's radio, but I'm up to date on the repair front. So, just going to have a look at this. See what I can do. First of all, sort out a transformer. I don't know whether it'll be this one. I've got a choice of 2 or 3 down there. So we'll sort that out first. I need HT. That'll be okay. I've got HT on this one, a couple of 100 volts. But the thing I'm worried about is the heater current. It's 6.3 volts. I need, well, 1.8 amps if I can. No, probably 1.5 amps. Anyway, I've got a couple of car bulbs, the old interior light bulbs here, and together I've disconnected the AVO now, but I checked the current. These are drawing 1.8 amps. Okay, at 6.3 volts. It's been on, what, half an hour. It's warm, but it's acceptable. See, I don't know what current that this transformer can supply, HT or LT. The HT will be enough. So when I'm running it at 1.8 amps, that's the load. See how hot it gets is the only way I can sort of find out, really. So when that's warm, but that's acceptable. And I don't think I'm going to be 1.8 amps anyway. I think it's going to be about one. I think I worked it out to 1.4. So I'm going to leave this on for 2 or 3 hours. See how it goes. Anyway, that's what this little setup is. The mains transformer there is getting warm. 2 bulbs drawing 1.8 amps at 6.3 volts. Right, what I've done, I've taken off the mains dropper and the little board that it's fixed to like that. I've taken that off. I'm going to keep this because we might want to put it all back together, or someone might, one day, someone might want to put it all back how it was. So that's how that goes there. Okay, the mains transformer I've fitted there. All the wiring's all over the place at the moment. The mains transformer is fitted just there nicely, as you can see. That's rather smart in there. A little bit of that coming off there. And we've got wiring off all over the place at the moment. Valves out, of course. And the next thing to do will be to connect mains to the transformer. Just wire that up to the on-off switch, and then wire the heater chain. And leave the HT for a minute. Wire the heater chain up because they're in series at the moment. We want parallel, so wire that up. When we've got heaters, I'll then start thinking about the HT side of things. Jolly good, lovely jubbly. I'm now wiring up the heater chain, which is all a little bit fiddly. I'm trying to leave as much as the original wiring in as possible. I'm just adding earth points here and there and the new heater supply here and there. So take it from series to parallel. Once I've done that, I shall put the mains on it and make sure that the valve heaters are lighting up as they should. And of course, when it's all done, it'll have an earthed chassis. Is this going to be the only DAC90A in the world with an earthed chassis and a mains transformer? Probably not. I would imagine someone's done this before. Right, onward with the heater chain. Now I've got the mains switched on. The valves are glowing nicely. What I'll probably do is take some close-up photographs rather than try and hold the camera here. There are so many videos like that around where someone's holding the camera and you can't see. So what I'm going to do is take some photographs and then you'll see those on the video. But we've got all the valves lighting up nicely, all getting warm. There we are, 6.3 volt heaters, no live chassis. Next thing is to do is sort out the HT side. Okay, at the moment I've only got the 2-pin mains plug. But what I will do is put a 3-core mains cable on it. I shall leave the 2 brass pins sticking out of the back as I always do, then little hole between them, just drill a small hole where the mains lead goes through there. The whole thing is, I want to be able to put this back, as I've said before, I can't state this too much, emphasize this too much. I want to be able to put the whole thing back to original without a lot of work. So I'm not destroying the radio as such. This is a small modification. I haven't cut out all the old heater wiring. I've arranged it. For example, the heaters all in series. What I've done is taken the heaters to that one. The wire that joins the 2 valves, earth it. I might draw this out for you actually if you want to have a look. Then the supply to those 2, etc. I'll draw that out actually, because I know that there will be 1 or 2 of you, if not several, 50 or 60 of you or more, who will think, I'm going to do that. Now it doesn't have to be a Bush DAC90A, it can be any radio with a mains dropper. All you've got to do is work out what voltages you need, find a suitable mains transformer and do all the necessary wiring, which I will show you. Okay, I shall now, I'm not showing you how I'm doing up nuts and bolts and soldering on pieces of wire. There's no point, you know, that's just a waste of time. But right, I shall now wire up the HT side, and I will, as I say, draw out a circuit exactly of what I've done, plus show you close-up photographs. Okay, back in a minute. Right, the story so far, let's clear up a bit of this mess everywhere, is we have HT and heaters, hence
to the revelations about MP's expenses. Well, it had to be seen to be.
The radio works.
Yeah, you could see it. Just anyway,
now, I can turn that off a minute. This transformer, I don't know how hot it's going to get because it's supplying rather a lot of heater current. I haven't yet wired up the dial light bulbs. They're going to be 6.3 volt bulbs now, of course, in parallel. What I've done, I haven't got a rectifier valve because a rectifier valve wants quite a lot of heater current, quite a few hundred milliamps. And I'm not sure this transformer can do it. I'm hoping to have a valve, but I want to see how hot the transformer gets. What I've done at the moment, I've just literally lashed in a little silicon diode, you know, what is it, a 1N4006 little diode type rectifier, and I've put a resistor in series with it. What did I choose in the end? I chose a 1K resistor, just as a current limiting, you know, anti-surge type resistor, because the trouble is with silicon diodes is as soon as you turn on the mains, HT is there, bang, straight onto the onto everything before the valves are even warmed up. So I don't like that idea. I want to have a valve rectifier, but at the moment, just to make sure everything's working, I've put in the silicon diode. So I'm going to run this now for several hours, see how hot that transformer gets. It's not the HT side that's the problem, it's the heater side. So we've got 1, 2, 3, 4 valves in this DAC90A. Ignore that wire, that's coming off in a minute. No rectifier valve, no live chassis, no mains dropper. Going to keep all these bits so it can all be put back together one day if someone wants to do that. So okay, there's another problem. The UL41, you know, the UL41 that all the DAC90As have, and they often have a problem with hum. Well, I found an EL41, okay, 6.3 volt heater, same valve. One slight problem, pin 4 I believe it is, I'll go into this on the circuit in a while. Pin 4 on the UL41 was used as an anchor point for some resistors. Pin 4 on this is cathode and grid 3. So I had terrible distortion. I thought it was a direct replacement pin wise, but no, it's not. So I've just had to do a slight modification on the valve base. Again, swapping a couple of things over, that's all, a couple of connections over. Nothing serious, nothing major. Okay, I'm now going to leave it running for a few hours, and I shall be back after a few hours, but we'll actually be back in a few seconds. Okay, it's all working very well.
On his third day.
The dilemma is this. This is getting too hot, or it was getting too hot. I can't fit a larger transformer to supply the current because it won't fit. Okay, so what I've done, the original UL41 obviously had to come out. I put in an EL41 6.3 volt heater audio output valve. The heater current on the EL41 it was 6.3 volts at 700 milliamps. That's a lot of current, 700. That's the EL41. Look up the EL42. Same pin connections, smaller valve, heater current 200 milliamps. I'm saving half an amp on heater current by putting in an EL42 instead of an EL41. Plenty of volume.
A South Korean company.
Yeah, loads. No distortion. What I've got to do is check the cathode volts, check the bias. I'm going to look up the data on the valve and just see how it should be run, what voltages it wants, and I'm just going to check the voltages on this one, make sure it's not being overrun. I think if anything it's the other way around. I'm going to have to check that. I still haven't got a rectifier valve. I don't think I'm going to be able to do that. I'm going to have to leave the silicon diode rectifier in there. I've increased the value of the current limiting resistor to whatever it is, 2K I think. I don't know if I can see it. Yeah, 2K. Okay, that's all right. I've checked the HT, that's okay. I'll go through the figures later. I just want to leave this on now. I mean that's warm, but it's not as hot as it was. It was really hot, so I'm saving half an amp on the 6.3 volt winding just by changing that valve. So okay, I've taken some photographs, so I'll go through one or two of the photos next. Right, in this photo, this is the front view of the chassis where the control knobs would be. There's the mains transformer, which fits in quite nicely. I've checked it inside the cabinet and it does actually slide. It doesn't touch the cabinet, it doesn't jam against the cabinet or anything. So you can see one lug of the mounting bracket of the transformer. I've had to bend down and bolt that to the front of the chassis. Okay, so that's the transformer from the front chassis view. This is from the side, the end of the chassis. You can see my bodge underneath there. That's the diode rectifier and its resistor, the current limiting resistor. The green wire, just see by the two valves there, that green wire, that's the center tap on the heater winding. which I don't need. I'm not going to cut it off because it'll, it'd be a shame to ruin the transformer by cutting it off. So I'm just going to just insulate that end with a bit of sleeving and roll that up and tuck it away nicely. So that's the end view, which you can see is bolted to the chassis there. So you've got two good mountings, two good 4BA nuts and bolts on that. Finally, we have the rear view of the chassis. Looks funny with the valve missing. The radio is actually working with a missing valve, but there we are. There's that green wire, that centre tap for the heater. I've just got to deal with that. All fits in rather nicely. Doesn't look too out of place there. You can see what I've removed, the two holes in that upright bar. That's where the board was for the various resistors, and the dropper, of course, which was on the right hand side. Okay. Right, R13, which is on that Paxilin board that the dropper's fixed to. There are 3 resistors in a row. R13 is on that board. It's a 10k resistor, and it having removed the board, obviously that's got to go somewhere else. If you look on the circuit at R13, you'll see it's across the smoothing capacitor from one electrolytic to the other electrolytic on the can. So all I've done, as I've taken that board out, I've got a 10k wire wound resistor, and I've put it directly onto the HT smoothing capacitor connections. Okay, that's R13. Now this is a view beneath the chassis. All you can see is a piece of blue wire I've added there. There's not a lot to see. This is the heater wiring from series to parallel. You can see that the brown wires at the bottom, the brown sleeving, I've not cut it all out. It depends how you want to do the heater rewiring, whether it's a Bush DAC90A or whatever make and model it is you're working on. You can either remove all the old heater wiring, or, as I've done, leave it intact. I don't want to change the radio about too much. So what I've done is leave the heater wiring there. So, and I've then earthed various points and taken 6.3 volts to the pins, as you can see. I'll draw this out for you. We've got bright sunshine now. I should be outside, not in here doing this. Anyway, I've changed the cathode resistor on the audio output valve. It was 150 ohms. That was for the UY41, okay, which is correct. This valve, I wasn't getting enough bias. This valve, the EL42, it wants minus 10 volts on the grid. Okay, so in other words, 10 volts on the cathode. I had, what was it, something like 3 volts. If there's not enough negative bias on it, it'll draw more current. The more, if you remember the valve videos, how valves work, the more negative you make the grid, as opposed to the cathode. That is, the cathode's positive, so the grid will be negative. The more negative you make the grid, the less current the valve will draw. So I've still got, well, that's a phone call, it's a bit tinny, but plenty of volume. Possibly could do with a little bit more volume. I've kept the HT low. That valve is now biased properly. Transformer, I'm now going to leave it on. By the way, the dial, let's turn him down, shush. The dial lights, I've used 6.3 volt bulbs at 60 milliamps. Normally you'd use sort of 300 milliamp bulbs. Well, that would be 600 milliamps, over half an amp. We're on a sort of power saving exercise here. We're trying to save power because of the small transformer. And you don't want this transformer getting red hot. It'll heat the cabinet up just as much as the dropper did, and the transformer will, all the wax will start melting out, and it won't last too long. Okay, we're getting there. We're getting there. We're actually on earthed chassis now. This is earthed. So, DAC90A, earthed chassis. Wow, this is rather good. Here comes an aeroplane from Shoreham Airport, so I shall shut up before he comes over and drowns me out. Okay, I shall keep you posted, up to date in a minute. This is the panel I've taken out. The far left resistor, that's the shunt resistor for the dial light bulbs on the series heater chain. So that we don't need. We're rewiring the heaters, that we can discard. That by the way is R16, the shunt. The one in the middle is R17. That's the HT, what they call the surge limiter. That's the one I've put on my silicon diode. I've put a 2K there. So that is in my modification here, that is redundant. The one on the right, the large one with the orange spot in the middle, that's R13. That's the 10K HT smoothing resistor. That is the one I've now put a wire wound across the smoothing capacitor tags. So that's that, and obviously the mains droppers on the right there, which we've also discarded. Okay, so that's that board covered. Right, this is showing the audio output valve base. You can see my mains cable coming in. You see where it goes to that earth tag, the green and the green earth lead and yellow earth lead. From that tag going left to the valve base is a resistor. That's the 680 ohm cathode bypass resistor I fitted. Sorry, cathode bias resistor I fitted. Okay, that was in place of the, what was it? Was it a 150 ohm in there for the original valve? I found the bias was low. So that's the 680 ohm resistor. What I've done on the valve base there, I've linked pins 3 and 4. That's where that resistor goes to. It goes to pin 3, and I've linked that to 4, because on the EL41, on the EL41, I'm now using EL42, but on the EL41, pins 3, 4 and 7, I believe internally are all cathode and grid 3. So I had to do this slight modification on the valve base. I mean, if you're going to do this yourself, the best thing is to just look at the circuit if you can and see what's going on there. But you can see what I've done. That suits an EL41 and an EL42. Okay, so I've just linked pins 3 and 4. If you look at pin 3, where the resistor goes to there, from that earth tag, go up and round the base. There's that light brown sleeving which goes to pin 7. Okay, so you've got 7, 3 and 4 linked up together, and the cathode resistor there to earth. And I've moved the other resistor, the 47K, which goes from that tag strip there on the corner to pin, what is that, 876, to pin 6. Okay, that's the control grid. You can also see from pin, where is it, 876, from pin 6, sorry, not pin 6, I've covered that resistor. That's the 47K to the edge of the tag board. The other resistor connected to the edge of that tag board that goes to the earth point, right, you can just see that's 470K, yellow, purple, yellow, that 470K, that I've moved as well. If you look at the original on your radio, you'll be able to see how it was and what I've done. And you can also see on here the heater wiring. That's the blue leads I've used, the heater wiring, how it goes into one pin of that audio output valve, and the other pin there, the blue, goes to earth. Okay, as I said earlier, I'll draw out the heater wiring for you. It'll vary on different radios, and you can do it, one of 2 or 3 ways. Right, I think that's covered that part. Here you can see the radio, the chassis back in its cabinet, all fitting nicely. Haven't got a rectifier valve yet. I'm still on the silicon diode. I've run this now for, where are we, for what, several hours, 3 hours it's been running, and that transformer is only warm, it's just warm, so that's solved that problem. Okay, 4 valve bases in a row on top, they are wired, the heaters are wired in series. That's pretty sort of self-explanatory really. Below, the same 4 valve bases wired in parallel. you'd put on the bottom one, which is what we want, where the two arrows are on the left hand end, that's where 6.3 volts goes. So they go to the 6.3 volt winding on your transformer. It's probably best to cut out all the old heater wiring on the top picture where they're in series, cut it all out and start again. If you're going to start leaving some of it in, as I did, it can become a little bit confusing. You're thinking, oh, what's that? So I'm taking that to there and that to there. So it's probably best to cut it all out and start again. Okay, that's basically all I can say about the heater wiring. This is basically how the radio was. Neutral to chassis, so that's your live chassis. Neutral to chassis. Mains into the dropper, live mains into the dropper, then through R1. R1 is the surge limiting resistor I've been talking about. That goes to the anode of the valve. This is the original circuit, don't forget. And then out of the cathode is HT positive to smoothing, etc. So that's the original, that's how it was. Obviously, it's a little bit different when you're looking at the chassis. I've told you where these resistors are, like the surge limiting one, and the dropper, you know where that is, you know where the valve is. But that's how the radio was. So now I'll show you, sorry about the rough drawing, it's not brilliant, but I'll now show you my modification. Mains transformer on the right, okay, the little winding, that's the primary, the little secondary winding where it says H, that's the 6.3 volt heater winding. They go to the valves wired in parallel. The winding above that, that's the HT winding. Okay, one side you want to take to earth, chassis rather, down to the chassis. The other side goes to R1. Same thing, that's the surge limiting resistor. Then instead of a valve, there's the little silicon diode. Get it round the right way. You've done it back to front. Get that round the right way. That's HT positive to smoothing as before. The chassis is negative. So it's pretty straightforward. But as I said earlier, it's easy looking at this on a piece of paper, but looking at it all on the chassis, you're thinking, well, where's this? Where's that? Hang on, where's this wire go? Now I've got a wire I've cut off here. I don't know where it came from. So, you're going to have to give this some thought. None of it's difficult, but as you can see, it does need working out. There are one or two other things I could have done. Dial lamps, I could have used LEDs, little LEDs of some description. I don't really want to have to do that. The transformer, as I say, it's running, where are we? It's warm, it's barely warm. That's fine, so that's all done. What I do want to do, actually I will just say one thing, it's gone very weak. All stations are very weak. And I've just checked a couple of other radios. I thought, oh no, what's happened? The transmitter at Shoreham, well, Southwick actually, which is what, 6-7 miles east of me, not far away. It must have developed a fault, because all the radio stations that come from that transmitter at Southwick are all very weak or not receivable at all. So I'm thinking, oh no, my radio's gone wrong, it didn't last 5 minutes. So yeah, I don't want to use LEDs. The transformer's okay. What I do want to do is, I don't want to have to change the rectifier valve base for a B9A or something. I want to leave it as it is. I will at some stage look into using a valve. The silicon diode is fine, it works fine, it'll last forever. But one of these days, when I get a little bit more time, I will look into using a valve. I've got customers' repairs piling up because I've been doing this. So there we are. I'm going to put the back on this in a minute and have done with it. No doubt this video is going to create a lot of questions. Where can I get a mains transformer from? Where did you get yours from? What sort of transformer do I need? All this sort of thing. It's very difficult. All the voltages that I've mentioned, it all depends on the radio that you're modifying from dropper to transformer, from AC DC to AC only. It depends on the radio. it depends on the valves, it depends on all these things, you know, what voltages you will need for the HT. Like the surge resistor I've put in there, the current limiting resistor in series with the diode or with the valve if you're going to use a valve. That depends on what HT your radio wants, what HT you're getting out of your transformer. So I can't say, oh, we'll go and buy this transformer or that one. Well, actually, there aren't any for sale, are there, these days? So you're going to have to use a second-hand one. I believe that one came out of a record player. If I remember rightly, that's from a record player, a very old record player. So there we are. I don't think there's a great deal more to say about it. So yeah, let's call it a day. Thanks very much for watching. Hope it's given you food for thought or whatever. If you've got a big radio, then you can use plenty of room in it. Take the mains drop out of that. You can fit a nice big transformer in there. You won't have all these current problems that I've had. Anyway, thanks for watching. See you again soon. Bye bye.